Okay, this next concept is very quick and it actually isn't super relevant to this unit, so it's just a kind of quick little introduction. And we're going to be talking about the mean value theorem that we discussed back in, I believe, the third or fourth unit of this year. I think it was the fourth unit of this year. But we're doing it relating to integrals. Now, I know you hated those theorems, and it's like, oh, don't bring back these bad memories. Luckily, this is actually very, very simple. And this is basically known as average value. And what this is it's the average height or value that you would get for an integral, I was going to say integral series, that doesn't make any sense, an integral equation. So let's say, for example, that we took the integral, and in this case we'll do y equals 2x minus x squared, I don't know, which would be x times 2 minus x. So it would look something like this. This is when your algebra comes back in handy. And 2 would be like that. So look like that, and you would have this integral right here. Well, if you wanted to find out, though, what the average y value for all of the y values that are in here are, because think of it, that an integral, I think I may have kind of skipped over this a little bit in the integral unit, but think of it, this is tons and tons of rectangles with tons and tons and tons and tons and tons, an infinite amount of different heights. It's saying what is the average height of the rectangles that are making up this integral. So what we're kind of thinking this as is as the picture I just drew that looks kind of like that. If you were to make a rectangle by crushing this down until there was kind of like a rectangle with the same area as this, but it's a rectangle and has the same width, what would this height be? And that's called average value. Very, very simple concept. This is the equation for it. It would be from a to b, and then your equation, so I'll just say f of x dx all over b minus a. That's it. You're basically saying you're taking the integral and you're dividing it by how far you went in the and the x direction. I can't talk, obviously. So let's take this example right here, and we're going to go from, I believe, 0 to 2, because that would make sense, wouldn't it? So, if we want to know the average value for this integral, it'd be 0 to 2, then 2x minus x squared dx, all over 2 minus 0, which is just 2. So for this, let's do a quick review of how to evaluate this. We would do add 1 to the power and then 2 over 2, which would just be 1, minus 1/3 x cubed. And you don't need the plus c because we're just evaluating the integral, and this will be from 0 to 2, still over 2. 2 squared minus 1/3 2 cubed, and you normally have to subtract by the 0 values, so because it's all of x's in them, it's just going to be 0. This is all over 2. You can then cut that off, make this a 2, and this will just be a 1. And you are left with 2 minus 4 over 3. 4 over 3. Wait, is this right? I feel like I'm doing this wrong. Wait, 2 squared is 4 over... You know, I'm just not going to do it like that. I'm definitely doing some math wrong here. Basically, you'll just do 2 squared, which is 4, minus 8 over 3. This is over 2. And you get 4 over 3, which is like 12 over 3 minus 8, which is going to be 4 over 3 over 2, which is 2/3. And therefore, for this equation, if you had the integral right there, and this, this height is 2, and this width is 2, and saying what is the average height for this exact equation, it would be 2/3. Not a very hard concept.